So we start with an assessment, which we call it as SAP Data Foundation Assessment. It evaluates your data estate across 5 interconnected dimensions, which are like your SAP Data Landscape, your integration and pipeline architecture, your data warehouse and storage posture. Again, then we touch upon data governance and quality. And also we touch upon the AI and analytical readiness as well. So the three condition, we already discussed, like Sham and Aditya were also discussing, like the unification, governance, and lineage. All these three will sit squarely within these 5 dimensions, basically. So, but the framework is broader because in an SAP environment, you cannot diagnose the AI readiness problem without also answering the architectural questions. Your SAP account team is already putting it on your table, right? So what do you do about the business data cloud? So the first dimension is your SAP data landscape and the governance quality. Before you even think about unification, you need to know the state of your core SAP master data. Even it can be your material master, it can be your customer master, and it also can be the cost center hierarchies. So are they complete? Are they consistent across the system? And are there any quality issues that has been tolerated? Because nobody have a mandate to fix them. So these are very important. Like we need to know all these things, and we also look into how data is structured and published via CDS views, and how much of your business critical logic is sitting in custom Z tables, and which may not have any standard schema. Okay, so we also run a structured diagnostic across these, and also it will give you a clear picture and a prioritized list of gaps that these gaps will be most directly impact your AI readiness. So we will give you a clear picture on all those areas so that you will be ready for the AI initiatives.
Yes. So Gobu, like once we have validated the quality of SAP data, like you discussed, I guess the next step is understanding the engineering perspective. So next step is where the data is actually moving through the organization, right? So the engineering part is that we look at the pipeline architecture, right? So how the data is currently moving from your SAP into the analytics environment, whether like if you have a data warehouse or a lake house or a simple semantic layer, or let's say it's a direct API based integration where you're just calling REST APIs and getting the data in. So we look at this source and we assess not only latency, transformation logic, how you're capturing metadata, and how you are handling errors at the source level, but also like overall reliability and observability of your data availability supply chain. So if you're looking specifically at this problem, we examine how ETL or ELT pipelines that you have is designed, how your dependencies are managed, whether you have existing data quality checks embedded into the process, or if you need more data quality checks. So how, let's say, CDC is handled where like there are some schema changes that happen sometimes, and whether like teams already have visibility into pipeline failures or delayed loads or incomplete data sets. So if something breaks today, like does the team know what has broken? So many organizations have like pipelines, let's say that were originally designed for reporting and dashboarding, which I mentioned earlier, like where an overnight batch processing was sufficient. So an example is that AI introduces a different set of requirements, like which often demands high data freshness, strong data quality, or significant higher or data traceability. So here, like we also evaluate the lineage operational readiness. For example, can the team immediately identify where a critical pipeline fails, or can they trace where a specific API originated, and can they understand like which downstream AI or analytics workloads are impacted when a schema change is happening? So ultimately, what we're asking is quite simple. If an AI model starts consuming from this data ecosystem tomorrow, what is going to break first? And when we have this answer, it typically reveals hidden architectural gaps that have been tolerated over the years because they had limited impact, because you are using a reporting dashboard, and this was not impacted in your reporting dashboard. But when you have an AI model, it's becoming a critical risk, right?
Yeah, so looks like a lot of depth covered for the pipeline architecture, Aditya. So it looks like you are checking how it is designed, you are checking how the failure patterns are and assessed, how quickly the team can detect failures. But my question is, if the pipelines are evaluated and if we take a deeper look at them through this lens, wouldn't and that means that they already have a data warehouse and a storage posture defined, right? Wouldn't it something that has to be looked because the governance clearly lies there, and also whether it is ready for AI workload consumption, right?
Yes, absolutely. So that brings me to one of the remaining dimensions, which is the data warehouse and the storage posture. So once you see that your ETL pipelines are working well and you're getting data correctly, we often underestimate the fact that your data warehouse is not well built. So it's not enough to have like data moving cleanly through a pipeline. Like if we have an end result or a sink that is raw and ungoverned, it is not something that an AI model will appreciate. And we look at whether your central trusted data repository actually exists, and how mature your data modeling at the sink is, and whether your storage architecture can support compute and access patterns that an AI workload demand, right? And like I explained multiple times, like many organizations we find are having warehouses built for aggregate reporting, and it's not designed exactly for feature extractions or low latency access that AI requires. So not just pipelines, we will be looking at the data warehousing side as well. And this gap needs to be on the table before we make any platform decisions on AI.